minima of the other that is to be there, and it is some sort of spectrometer is going to be used, and what exactly this acoustic grating is meaning to be there, that we will see in detail. So moving forward to be as a acoustic grating, simply before going to the theoretical part, it is simply you have to look at this, how this arrangement is to be there as far as the acoustic grating is to be there. This is what the spectrometer is to be there, and in this case here it is to be as an sodium light or the lamp. Yellow light, that is to be the sodium light, is to be there, and the mercury light is just like as a tube light or LED type of the street lights are to be there. Now here in front of this there is a collimator through which the beam of light with the lens, uh, this is what the sodium light will generate as an ordinary light, which will be in the all the direction will be, it will be there. But this collimator contains one slit, and that through which there is a lens, here it is to be as an one lens, and that through the ordinary light when incident on this lens, the parallel beam of light will come out, and here is the parallel beam of light is coming out. In between this there is a resonator tube, and here it is to be as an simple tube which contains the your two ends with the plates, which is given audio frequency is given to this particular two plates AB. In between this there is a quartz crystal is placed here, and here is the one R, that is R is nothing but to be called as a reflector, where the whatever be the waves are coming towards this, it will get reflect back in this direction, and due to this superposition of these two waves, either coming from this and the reflected wave superimpose, and the standing wave pattern or the stationary waves will generate, and that will gives you the acoustic grating effect. Here it is to be as a telescope, where through which you can have the lens, and that through which you can see either your eyes through your telescope is to be there, or you can say the screen is nothing but to be your eye, where you will see the central bright maxima at the, and another the diffraction pattern will be formed in this fashion. The it will be central bright, and this will be the for first order, and theta is to be there. You will find the different patterns or the second order, third order, it is also to be there. This is what the arrangement of this particular acoustic grating is to be there. Now in this case it is completely as a spectrometer. You will learn again the sodium light through which the grating you always use for the generally finding the velocity, particularly calculating the wavelength of the sodium light using that experiment. You will the same experimental setup is to be there, but you use there the grating is to be there. And how is grating is to be made? Grating is simply nothing but to be a one glass plate, transparent, where of it is of nearly 1 inch in size basically, and there are nearly 10,000, 8,000 or 15,000 lines are to be there, where the transparent and opaque part is to be there, and through which light is going to be through the transparent part, light will go, and opaque part the light will be diffract. Now in this case the both the lengths, or that is to be the thickness of the opaque part and the transparent part is going to be same, and in 1 centimeter nearly 1 inch there is a 8,000 or nearly 15,000 lines are there, equally distributed. A and B are to be there, according to that the transparent and opaque part is to be there, and that is nothing but to be called your grating is to be there. Now the same thing here, the grating is not there, here the your ultrasonic waves will work as a grating, and that's why this particular case is nothing but to be called as a acoustic grating. Now we will see in detail how this is going to be formed as an your basically how the acoustic grating works. The basically this is what the quartz crystal is going to be used. Two plates are to be connected with the audio frequency oscillator, that is I already told you. The same thing is to be theory is to be here, and in this case basically this is what the sodium light through which the ordinary light will come in this collimator, and through this collimator a parallel beam of light will come out, and at this stage at A and B there are the two plates, A आणि B या दोन प्लेट आहेत, आणि ह्या दोन प्लेटला ऑडिओ फ्रिक्वेन्सी म्हणजे इन एक्सटर्नल फील्ड आपण अप्लाय करणार. आणि ह्या बिटवीन हा इथं आहे तो क्वार्ट्ज क्रिस्टल. आणि आपल्याला माहिती आहे की बेसिकली तुमचा जो पिझो इलेक्ट्रिक इफेक्ट आहे त्याच्यामध्ये आपण बघितलेलं आहे की सेम पिझो इलेक्ट्रिक इफेक्ट इथं होतो आणि अल्ट्रासॉनिक वेव्स जनरेट होतात. पण आता ह्या ठिकाणी बघा, ज्यावेळेस ए आणि बी हे दोन पर्टिक्युलरली प्लेट्स आहेत, तर एकाला पॉझिटिव्ह आणि एकाला निगेटिव्ह चार्ज दिलेला आहे. आणि त्या केसमध्ये ही क्वार्ट्ज क्रिस्टल आहे, ही क्वार्ट्ज चिप जी आहे किंवा क्वार्ट्ज क्रिस्टल ठेवलेला आहे. आणि ह्यामध्ये काय होते की इथं ज्यावेळेस ह्याच्यामध्ये बेसिकली ऑडिओ फ्रिक्वेन्सी ऑडिओ ॲज अन oscillator as and to be work here the input is to be given through the external field. आणि त्यामुळे त्याच्यामध्ये जे काही व्हायब्रेशन कॉन्ट्रॅक्शन अँड एक्सपान्शन होते. आणि सॉरी त्याच्यामध्ये बेसिकली जी काही पॉझिटिव्ह अँड निगेटिव्ह चार्जमुळे ह्याच्यावर जे काही टोटली ऑपोजिट साईडला हे चार्जेस दिल्यामुळे दुसऱ्या साईडला त्याचं कॉन्ट्रॅक्शन आणि एक्सपान्शन होऊन व्हायब्रेशन्स जनरेट होतात आणि waves as in it works as in it gives you the waves are to be there, and these waves are going to be in this direction. या जनरेट झालेल्या waves आणि या डायरेक्शनला जातात. पण ह्यामध्ये पुन्हा एक महत्त्वाची केस, जेव्हा एक्सटर्नल अप्लाइड फील्ड ह्या नॅचरल फ्रिक्वेन्सी सोबत त्या तुमच्या क्वार्ट्ज क्रिस्टल सोबत मॅच होतात, रेझोनंट व्हायब्रेशन्स आर गोइंग टू बी generated, and these waves are produced to be as an max will go in this direction. Now while going through this means that is to be as in your ultrasonic waves, here is one reflector is to be there which will reflect 100% and it will come back, the same waves will come back. And what will happen, the two same waves, that means one wave is going to be in this direction and the another is to be reflected in this direction. That means what will happen, why waves are going in this direction also, after reflection they are coming back in the same direction. And what will happen, that the two same waves of the same frequency, amplitude and time period, when in opposite direction in a straight line superimpose, the standing wave pattern or the stationary waves are going to be generated. And here is the same phenomena, it will happen at this stage and the stationary waves will generate, and these stationary waves generated works as an grating, where I told you how the grating is to be there, and it looks like to be as an opaque transparent like part. And due to this, whenever the light beam is going to be sodium light beam is going to be incident on this stage, it will works as a diffraction pattern. This acoustic grating is to be works as a diffraction pattern, and you will get there through this telescope a diffraction pattern at the screen. This is what all the things are going to be happening. Now with this case, using this spectrometer, we are already aware, or you will get this experiment totally in the your practical lab work, that how to calculating this such type of the arrangements as nothing but to be called your acoustic grating. And this will give you basically how to calculate the your wavelength in that case also, or you can also calculate the different velocities for this particular ultrasonic waves also. Again in this case, the telescope view, the diffraction pattern consists of central maxima at the principal maxima and those both the side, the maxima on the either side. The direction of the principal maxima are given by the expression in simply way. You will also get it in the your practical lab work, that d sin theta n is equal to n lambda. आणि हे जेव्हा हा पाथ डिफरन्स जेव्हा दोन्ही मधला सेंट्रल आणि ह्याच्यामधला हा जेव्हा किंवा तुमच्या एन लॅम्बडा म्हणजे इन्सिडंट वेवलेंथ एवढा असतो, त्यावेळेस डिफ्रॅक्शन म्हणजे जे काही तुमचं पॅटर्न आहे, डिफ्रॅक्शन पॅटर्न इज गोइंग टू बी फॉर्म. दिस इज व्हॉट द सॅटिस्फॅक्टरी कंडिशन, डी साइन थिटा एन इज इक्वल टू एन लॅम्बडा. मग फर्स्ट ऑर्डर असेल तर एन विल बी 1, सेकंड ऑर्डर असेल तर एन विल बी 2. अकॉर्डिंग टू दिस थिटा एन 1 or n is going to be 1, or theta 2 or 2 lambda, that will be the n value is going to be changing. This is what the relationships are to be there. Now this n is going to be 1 2 3, likewise I said that order. Now what is this particularly first order second order maxima? We are talking about this central bright maxima. हे जो bright maxima इथं जो काय येते हे फर्स्ट ऑर्डरला आलेला. ह्याच्या पुढे पण असाच येईल सेकंड ऑर्डर. ह्याच्या हा सेंट्रल ब्राईट आहे, हा फर्स्ट ऑर्डर. ह्याच्या पुढे पण एक मिळेल तुम्हाला सेकंड ऑर्डर, थर्ड ऑर्डर. दॅट विल बी द n इज गोइंग टू बी 1 2 3. अँड व्हॉट इज दिस? दिस इज व्हॉट द थीटा अँगल. थोडं फर्स्ट जर ऑर्डरसाठी घेत असतो आपण तर दॅट विल बी θ1. सेकंड ऑर्डरसाठी घेत असतो तर दॅट विल बी θ2. थर्ड ऑर्डरसाठी घेत असतो तर θ3. लाईकवाईज द थिंग्स आर गोइंग टू बी वर्किंग. नाउ इन दिस केस बेसिकली